Today we'll be looking at Git flow procedures and specifically how you might want to collaborate on your projects. So GitHub is a collaborative programming platform which allows you to keep track of your changes to your code base and as well as that, test out some of the potential issues with your code. So once you have your repository set up, you should have your main branch, or sometimes it's called the master branch, which contains the latest, most up-to-date version of your code that is working, that is released, that everyone is using. Once you decide to stray off that path and set up some new features, you might want to create a new branch using a Git checkout, which is essentially a copy of your main code base. And in today's paradigm, most developers are using Git flow, which contains the most up-to-date version of your code that is on the main branch, as well as something that is currently being iterated on, which is the develop branch. So whenever you have this movement from one branch to the next, you can think of it as being a copy of the entire code base at this particular point in time, right here. But that iteration from one branch to the next is done by copying over the entire code base. You then make the necessary changes, ensure that they work, and your teammates might also be doing the same thing. However, if you're working on different files and different folders, this might not pose any issues, but if one of you ends up creating some changes that affect the entire code base, for example, they might have modified a file that someone else has modified, you will encounter a Git conflict, and we'll have a look at how to try to resolve those. So the procedure for working with Git and GitHub is such that you first make some changes to your code base. Once you have cloned the entire repository, which is going to be item number 0 at this stage, you can then make necessary modifications to your code base. And this ritual is something you'll all be familiar with at this point, where you first fetch the updates, git fetch, git pull, updates from the repository that downloads any necessary changes to your code base. After which, once we've modified something, we can iteratively work on different features, on fixing different bugs. We can then do git add. That adds all the files to what's called this staging area. If you've added a file to the staging area, that means you are happy with the way it works currently, and you would like Git to start tracking those files, those changes that you make to those files. This doesn't mean that they are going to be on GitHub straight away. For that to happen, we need to do the next two steps, that is commit and push. So add dot stands for add all the files in our current working directory, in our current repository. Git commit means that you are happy with the changes you've made and you would like to say to other users of your repository what you've changed. And that can be done with the M flag, git commit -m for message, and within quotation marks, you should write your update message that's going to be available on GitHub for everyone to see. Once you've staged it, once you've committed the changes, you can then push them, that is to upload them to your repository. And this flow is something that you'll be going over and over again. You'll pull the updates, that is get any changes that have been made, add those updates to the staging area, so start tracking the files, commit the files, explaining what you've changed, and push them, that is to upload them to GitHub. When you are setting up your repository, as I have previously mentioned, you might want to work on different branches. So for example, if it's the case for your team that you have multiple people working on multiple different tasks, exercises, problem sets, it is a reasonable approach to separate them all out into different folders and different files. separate files, separate folders, ensures that you are working on different features at the same time, working asynchronously on your project. If you are done with all the changes that you have made, you can then go through the same ritual, that is add files to the staging area, commit, make a commit message saying what you've changed, push the updates to GitHub, and if you're working on a different branch, you can then make a pull request, that is a request for everyone else on your repository to review the changes you've made and approve them. If that happens, you can then merge them back into the main branch for everyone else to see. So let me just illustrate this here. Let's imagine that you're working on feature 1, right here. Feature 1 is a new branch that is the ancestor of the develop branch. In our case, you will not be using the develop branch, you can just keep on using feature branches instead. So you've done this add commit push ritual, you are happy with the changes that you've made, you've ensured that nothing that you have changed breaks other people's code. Then you go onto the GitHub web interface and make a pull request. A pull request is basically like a forum post where you say what you've changed and you allow other collaborators to comment on your changes and see that there are no issues with them. Once those changes have been approved by your collaborators, you can then proceed to merge them into the main branch. So this is the same for feature branches to develop branches. It's the same for develop branch to main branch as well. If there are some merge conflicts, which is what happens when you have changed files that someone else has been working on, you'll then have to resolve them in your code editor and go back through the same process and submit another pull request review. Now, one other bit of the theory is that when setting up your repository, depending on the tech stack that you are working with, whether it's JavaScript, Python, Go, C, and whatnot, there are some files that we don't want committed, either because they are not necessary or because they are sensitive. For example, env files contain API keys, and that will put your credentials at risk. So you would never want to expose your API keys, you would never want to expose your web tokens, because other people might be crawling GitHub for those exposed credentials, and GitHub will actually warn you at some point if you've committed them, saying that you've exposed your credentials. Also, overly large files like databases, so something that exceeds 100 megabytes, should not be committed directly to GitHub. There is something else for that called large file storage. This is not free, unfortunately, but there is a generous free tier allowance, which does allow you to push some databases over to GitHub if that's necessary. So within your gitignore file that is going to be set up when you create your repository, you should choose the appropriate language and maybe add some other files. Like for Macs, we might want to add a .ds_store file, because that's what Mac creates by default when working with folders. And when you have created a virtual environment for your project, you should never commit that either, because there are tens of thousands of files that is simply a copy of a Python installation, which doesn't need to be on GitHub. You can just download that from elsewhere. In the case of JavaScript, for example, you wouldn't want to commit node modules file, which contains the same kind of stuff, just installations of node modules, node packages, JavaScript packages. All right, so let's now start off putting all of this into practice by creating a new repository, calling it something like git-demo, making it public, and ensuring that we have a README file as well as a gitignore file for Python, depending on what you are working with, whether it's JavaScript, Python, they'll have to provide different gitignore file templates. hit create the repository and then copy over the link to it. So go over to your VS Code and open up a new folder. So I'll just open this up in my project folder and simply run git clone and paste the link to the repository I've just created inside the terminal. Once this has been copied over, you can then open folder again and inside the projects folder, find the repository you've just created. So here in the projects folder, we have our Git demo repository. Open it up so we don't have any of the stuff on the left distracting us. Open up the terminal and run git status, which will show you where you currently are and what is being tracked. It says we are on branch main, it is up to date with origin main, and there's nothing to commit. We can change something here. For example, provide a description of this repository. This will do. As you can see, we have these lines being demarcated with green, which means that they've been modified. Also, on the left-hand side, we can see that M stands for modified as well. You will have D for deleted and A for added in red and green, respectively. So run git status now. Status again. And it says that it's been modified, but those changes have not been staged for commit. To do that, we need to run a git add command to add those files to the staging area. Git add dot to add the whole current working directory as something we want to be tracked for Git. Run git status once again, and now it is being tracked. So from red, it's turned to green. Changes to be committed as opposed to changes not staged for commit is the difference. Once we are happy with the changes we've made, we can commit with a -m message and explain what we've done. Changed readme. So one file has been changed. There have been 5 insertions, 1 deletion. That is the number of lines you've affected. And if we go back to the same repository, you will notice that no changes have yet appeared in here. For that to happen, we need to git push. Git push, and then it will upload the changes we've made to the repository. Here we go. Just refresh the page here, and you will be able to see that description we have just created over here. So far, we've just been working on the main branch, but if you're working with somebody else, or if you're working on multiple different features simultaneously, it is a good idea to separate them into different branches. So let's just imagine that we want to create a feature for a hello world file. And on the left-hand side, we can still see that we are in the main branch. Let's switch over to another one by creating it. Git checkout -b and the name of the branch, hello_world. Like so. It says we've switched to a new branch, hello world. On the left-hand side, we can also see that it's been changed. You can try and do the same thing with the graphical user interface instead, which works just the same way. And on the left-hand side, we will be able to see that this branch has not been published yet. So in order to do that, we need to make some changes, like, for example, adding a hello.py file and simply print hello world here. Make sure that your file has been saved. If you can see a white circle over here, not you, not anything else, this means that the file hasn't been saved, and instead you'll need to ensure that your autosave functionality is toggled correctly. You can do so by pressing Command-Shift-P if you're on a Mac, or Control-Shift-P if you're on Windows, and simply searching for toggle autosave. Toggle autosave, this one. Make sure that's enabled. And let's do the same procedure we did previously. Git dot, git commit, git push, git add dot, git commit dash m. So that indicates we are happy with the changes, and this file has been added. For a good hello world program. One file has been changed, one insertion. Then if you try to use git push at this stage, it will say that there's been a fatal error. Don't worry about this. This just indicates that we have not set an upstream branch. So simply copy this command right here, paste it in, and it will set the upstream branch as well as put our changes to it. Hit enter, then go back to the repository and check that it has taken effect. So we can now see a compare and pull request button here. We can also see that we have two branches. One is the main branch, so our default branch. Another one is hello. If we look at the main branch, the file is not here. If we switch to the hello world branch, it should be there. So hello.py, click on it, see it's indeed been updated. And we can see how many commits, also what commits we've made. So we've made an initial commit, changed our README file, added a hello world program, and these little numbers are your commit hashes. So if you want to revert some commits, so go back in time and iteratively restore some of your other work. So perhaps you've deleted something that you didn't want to delete, or you've pushed some sensitive information. You can use those commit hashes that look like this, just a huge number indicating what you've changed, the name of your change. So you can use that with git revert to go back in time. Now, once you're happy with those changes, you can compare and pull request. Let's press this. And there we'll describe for our collaborators. Let's just add John as a reviewer here. And I will add myself as an assignee. Could you please change? Could you please check, sorry, whether we can merge this. This little comment window accepts Markdown, and what's useful about it is you can also have checkboxes here that are formatted like this. Check the hello world program. Preview that. This is what it's going to look like. So whoever is answering this pull request will be able to comment on it. So think of it as just a blog post. Sorry. So think of it as just a forum post which people can vote on and review. Create a pull request. Then once John is happy with those changes, he could check this box or request some changes. Okay. And Git will automatically check whether there are any conflicts with the main branch. We can look at how many files have been changed. So the hello.py file has been created. This is what's changed about it. Also, you can write some comments like nice change, and submit your review. If you have been requested as a reviewer, you will also be able to approve those changes. And again, GitHub will check that those changes can be merged into the main branch, that there are no conflicts. After which you can automatically merge this pull request and delete that branch. merge pull request, confirm merge, and then delete the branch. There we go.